Yeah, my name's Dave McKeown. Let me tell you a story. The story is when I was 8 years old and I was in school and I got in an argument with one of the older kids. And it was about whose dad was oldest. And he said, well, my dad's 20. And I said, well, my dad's 40. And he said, well, my dad's 60, 80, 100. And then one of the other kids said, well, my dad's infinity. And he had won for a while. And then someone said, well, my dad's Hulk Hogan. And he won. We all agreed that Hulk Hogan was bigger than those. And I went home that day and it was kind of a bit sad because I'd lost this counting game. And I vowed that day I would find a number which was bigger than Hulk Hogan. Okay, so now the eagle-eyed among you will have noticed that Hulk Hogan isn't technically a number. Right? Like this. Hulk Hogan's a wrestler, isn't he? He's a very good wrestler, 12-time world champion. But let not that put us, away from looking for it. Let's continue our search. I'm sure we can find something bigger. And the problem with finding bigger numbers is that we're not used to looking at big numbers. It's very hard for us to understand big numbers. A very famous big number is a Google, which is 1 with 100 zeros after it. The search engine's named after it. And it's hard. I said, imagine a Google of dinosaurs in a field. Could you imagine? You can't imagine. I can't imagine what that looks like. So what we tend to use is units to make things smaller, so we get something. So we can kind of think maybe somewhere between 0 and like a million or a trillion. But after that, our minds get blown. But mathematicians, they use big numbers all the time. And if you look in the Guinness Book Records of 1980s, there's a section about big numbers. It's not as cool anymore, Guinness Book World Records. And it has a number in there called Graham's number. And Graham's number is massive. It's absolutely massive. So let me explain it big. Big, it doesn't even explain it. If you try to write down all the digits on all the atoms in the observable universe, you couldn't write it down. There's not enough. You've got the Planck volumes, which is the smallest space that you could put something. You couldn't fit it in. If you try to think of it in your brain, there's too much information in there that your brain would collapse into a black hole immediately. The entropy is not enough. Okay? So it's just absolutely massive. So if a number like that's Ronald Graham on the right, is that bigger than Hulk Hogan? Well, Hulk Hogan could fit into Hulk Hogan's brain. But Graham's number couldn't fit into Hulk Hogan's brain without creating a black hole. So therefore, Graham's number must be bigger than Hulk Hogan. Now, people are saying, okay, well, what about infinity? People will try to say infinity and try to cheat in that game. Infinity is not a number, but people will play it. So if someone says infinity is at the end of the game, can you get bigger than infinity? Well, no, and yes, just different kinds of infinity, and some infinities are bigger. So what does it mean for something to be bigger? Well, we can have sets. We can name things, so that's things with heavy things in it, anchor, piano, and then a set with the members of the popular Irish band, the Corrs. So which set is bigger? Well, we can draw lines from one set to the other set. And then when we pair everything off, at the end, if anything's left over, well, then that set is bigger. So in this case, we're left over with bus, which would suggest that the heavy set is bigger than the core set. Okay, so can we do that with infinities? Can we list one infinity and then list another infinity and pair them off and get one infinity that's bigger? Sorry for that. Right, so one infinity there is all the natural numbers. So 1, 2, 3, 4, 5, 6. Keep on counting up. And 1 is all the decimals, we say between 0 and 1. It can be between anything. And we can pair them all off. So for every number, whole number, we can pair off with a decimal. But when we have paired all those things off, is there anything left over? Can we add something on the list to make it bigger? And it turns out for the decimals and not for the natural numbers, we can always add something to that list. We can always add a new number, which will make it bigger, which is not true for the integers. And we can make that number by taking those numbers that are circled. If we take all those numbers and we list them out, and then we add 1 to them, we get a new number. So in this case, 2, 3, 4, 5, 6, 7. We can add that to the list. And we know it's not on the list because it's not the first number because it's different than the first digit. It's not the second number because it's different than the second digit. It's not the third number because it's different. So it's always a new number. And that means that the infinity of decimals is bigger than the infinity of integers. And okay, so the ones of integers is called a countable infinity, and one of decimals is called the uncountable infinity. Okay, so the next day I went back to the playground. And he said, well, my dad is older than your dad, my dad's 20, my dad's infinity. Well, my dad's uncountable infinity. He said, well, my dad's Hulk Hogan. And I said, my dad is Graham's number. And they walked away, and they never talked to me again, and that's how I knew I had won. Thank you.